Understanding AAMA 501.6 Dynamic Racking Crescendo Test for Determining Glass Fallout. Welcome to Building Knowledge 101. In this video, we look at the AAMA 501.6 standard and the complex process of determining the horizontal racking displacement amplitude of exterior wall system framing members that could cause a glass fallout. And in terms of doing that, engineering analysis would be to do AAMA 501.6, the dynamic racking crescendo test for determining glass fallout. So this is determining the horizontal racking displacement that will cause the glass to fall off a current wall system. Again, while AAMA 501.4 deals with serviceability, you're doing air and water testing. AAMA 501.6 is a standalone test that just deals with determining the glass cracking and the glass fallout. The scope of this test will be curves, corners, blade mullions, and multi-story test specimens. This is an example of a chamber for AAMA 501.6 testing. So we want to replicate real-world scenarios. So the system is mounted in a test chamber just like it would be mounting on a building, where if have these steel tubes acting as your slabs, and the current wall system would be mounted to the exterior of those with a wind load and dead load anchor. And then for a window wall system or storefront system, where instead of being mounted to the exterior of a building, it's mounted slab to slab, is mounted the same way in the test chamber, where instead of being on the exterior of those steel slabs, it is in between those steel slabs. In the right corner, this is actually an example of the crescendo graph. So you can see you start off with at 0 movement, and you increase up to 6 inches movement at a certain frequency. Again, this is just another picture of the actual test chamber. So you can see, mimicking real-world solutions. Again, your simulated slab, which is these steel tubes, and you have your wind load anchor here, and then over here you have your dead load anchor. In this case, this top steel tube is fixed, and then your bottom tube can rack back and forth to simulate the seismic activity. And this is just some pictures from testing. So in this bottom left picture, you can see glass cracking, and you can see some small glass chips. And on the right, you can see the displacement graph. You see us starting off at 0, and then eventually ramping up to 6 inches of movement.
That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.